Okay, so we're going to be going over the solution to the 30th problem in the grind 75. This one is 3-sum. So given an integer array nums, return all the triplets such that the indices are not the same and the elements add up to 0. So as the name implies, it's something similar to 2-sum in which we're taking a certain number of values and we're trying to add it up to some value. This time 3 values, 3 distinct values, and we're trying to add it up to 0. And the way that we're going to do this is by first treating this value as our target and then performing 2-sum on the rest of the array. And essentially, because we want to get 0 and this is our target value, we're actually going to make the value we sum up to the inverse of our target value. So that when we find two numbers that sum up to 1, they'll cancel out this -1 to give us the 0 that we really want. Okay, and the way that we're actually going to do this is to use the two-pointer system, which when we use the two-pointer system for 2-sum, we have to sort the array, which costs O of n log n time in Java because Java internally uses the quicksort algorithm to sort arrays, or something similar to the quicksort algorithm. And while this seems expensive, the bottleneck operation in this algorithm is actually going to be O of n squared. So this operation doesn't really, the above operation is negligible. Okay, so we're actually going to start out by sorting, and we can sort regular Java arrays by calling arrays.sort. And we can just call it on nums. Okay. And the next thing that we're going to do is create our result, which has to be of this form. So we're going to say a list that has lists of integers in it. You can call it result, is going to be equal to a new, and it doesn't really matter, we can say array list for the concrete class. And we're going to leave the type of list inside of it up to, we don't actually need to specify it. Once we start adding to it, then the type will be defined. Okay, and what we're going to do now is just iterate over the nums array, and we're going to say for int I, starting off at the first index, as long as it's less than nums.length minus 2. The reason for this being, if we want to perform 2-sum on values after a specific value in nums, we have to have at least 2 values to sum together, right? So looking at this example, this will be our last value because we need 2 more values after it to sum together to check against this value to see if they will all sum together to equal 0. Okay, so we're going to do that, and then we're going to create our pointers. So we're going to have a low pointer that's going to be initialized to 0. We're also going to have a high pointer, and actually it shouldn't be initialized to 0. It should be initialized to the index right after the current anchor, is what I like to call it, the current anchor that we're on. And our high, that's always going to be reset to the same value, which is the last element in the array. And then we can call this int 2-sum, and that is going to be equal to the value at I, but we're going to take the inverse of it. So we're going to say 0 minus that. Maybe I should just call this sum, actually. Really, we want low and high to sum to that value. Okay, that's good. And we're going to say, for as long as low is less than high, not less than or equal to, because we don't want them to be the same indices, as we can see by this here. While this is the case, we are first going to check if, let's see, give me a second. Right, so we want to see if the value at low and the value at high, when summed together, do they equal the sum that we're looking for? So if, what is it? Nums at low, and let's put this in its own set of parentheses. Say nums at low plus nums at high. If that equals the sum that we were looking for, then we can do the following. We'll say arrays dot as list, and then we can just pass in all the values that we want to input into this list, or I guess triplet that we're making. So we'll say we want nums low, nums high, and nums at our anchor value. Right, so that's going to create that list, but we want to add it to result. So we're going to say result.add this. Arrays.asList. Yes, this should be correct. Okay. And then because the array is sorted, and because we can find duplicate values, or we can have duplicate values, all duplicate values will be right next to each other. So we can actually have a condition that ensures that we skip over any duplicate values. We also want to be checking that we don't exceed, that low and high don't exceed each other. Because what we're going to do is first check on the low side to see if it's right next to a duplicate value. So, well, that's the case, but really, well, low at the current index, I should say num at the current index is equal to nums at low's next index, then we're going to want to move low on. Similarly, and actually, low is going to increase. Similarly, if high is right next to a value that is the same as it, then we're going to want to skip past it. So we're going to decrement high. All right, and then once we go past both duplicates, that means that we've found a successful pair, and we don't want to use the current value that we're on. So if we say we have multiple duplicates, this will stop on the very last duplicate. So we do need a condition here that just pushes our pointers over the edge to two completely new, fresh values. So that is our first if case. If our low and our high plus our anchor give us the value that we want, which meaning they sum up to 0, then we just add to the array. Otherwise, we just have to increment the pointers accordingly. So if we have this case, but we say overshot, that means that we're going to want to bring down the higher value that we're contributing to the sum. So we're going to just decrement high. Otherwise, meaning we undershot, we're just going to want to push up our lower value. All right, and that should be it, unless I made some syntactical errors somewhere. Let's just return result. And let's see. What's this? Else if nums low plus nums high is greater than sum. Illegal start of expression. So if, where does this if end? I'm going to say it ends there. I'm going to put this here. That, there. Okay, should be okay now. Okay, what does it say here? Some extra parenthesis there. Else without if. No, they should all be part of the same. Where does this if statement end? We do not want that if statement to end there. We want it to end down there. So push this back. Okay, this should be correct now. Unless there's some other error, of course. Which there is. Okay, I'm going to pause and just clean out the errors really quick, but the logic should be there. Alright, so one last little thing. We were having a lot of issues with the curly braces, but we fixed that. So if you remember, we were checking for duplicate values here for lows and highs. Well, we also have to do the same thing for when we're iterating our anchor point, or that start point. So we're going to have a check. If our I is equal to 0, or I is greater than 0, and nums at I does not equal nums at I plus 1. And that just simply checks for a duplicate value. And so we're going to take everything that's inside of that for statement, put it in there, maybe hopefully fix some of the indentation. Okay, that looks nicer. Let's hit run. Actually, it has to be if I is greater than 0. Let's run. Let's see. Okay, what else is going on? Okay, we just have to change. We had this before, and we just have to check for the value before I. So we're going to hit run. Okay, that works. Alright, and that has been the solution to the 30th problem in the grind 75. This is threesome. I originally tried to implement the solution using sets of some kind so that I wouldn't have to do all these checks for duplicate values. Instead, I could just create a set of the triplet and then check it against existing sets of triplets, like the existing set of triplets, and if it was there, then I would just move on. But I was not able to figure out a way to do that. Plus, if we were to make a set on top of this array, the space complexity would double too. So that would make things a bit more inefficient.